this next section, we're going to talk about probability distributions. So far we've talked about probability and how it kind of affects certain outcomes. We have different events, and you can go ahead and find the probability of that event occurring. So there's a lot of things that go on with probability, and it involves a lot of thinking, and there's some formulas as well. So here what we want to do, we want to combine the data, which is what we've learned from the very beginning of the class, with the probability. So data and probability are now going to be combined. So the first thing to do when we're talking about probability distributions, let's go ahead and first start off with something called a random variable. So basically what a random variable is, it is just a variable that is determined by chance. Okay, so this is a very different type of variable that we've worked with before, because if you think of variables in terms of algebra, you can think of x, solving for x. There's one solution, maybe even two solutions to this particular value of x. Now, this random variable is determined by chance, so it really just depends on maybe what you're looking at. So one example that you can kind of think about is, for example, weight and your height. Your height is a variable that is determined by chance, because if you try to find one person who's really, really short, that is going to be very different than finding another person who's very, very tall. Notice that the differences in heights are going to be very different, okay? And, I mean, you might encounter more people that are maybe 5'8" as opposed to someone that's 4'9". So it really is just determined by the chance and the way that you can kind of encounter these different observations. So what I'm going to do is I'm going to refer to random variables as RV. So instead of writing random variable over and over, I'm going to write RV. Okay, so RVs can be broken down into two different types. Okay, so there's two different types of random variables. So you have continuous random variables, and you also have discrete random variables. Okay, so an example of continuous random variables could possibly be like, for example, your weight, your height, your income. Okay, so anything that you can express as a decimal or as a fraction is going to be continuous. So I'm going to write it right here, can be expressed as a decimal, or some sort of fraction. So something that can be expressed like that, then it's going to be a continuous random variable. Now a discrete random variable is still the same thing, but some examples of discrete random variables are, for example, your siblings, the number of siblings that you have. Okay, so maybe I should write number of siblings. Okay. It can also be, I don't know, the number of students in the class. Okay, so notice that all of these are what we call whole numbers. So these numbers are whole numbers. Okay, they can also be integers. And integers, what they basically are basically all the positive and negative numbers. So basically what discrete don't have is there's no decimals. You cannot express a person in terms of a decimal. You can't have 1 and 1.789 siblings. You can't have that. You can only have 1, 2, 3, 4, and so on and so forth. So there's no decimals when we're talking about discrete random variables. If a random variable can be described as a decimal, then you can call it a continuous random variable. Okay, so let's do a couple problems talking about random variables. So here are 4 different questions that you can go ahead and take a moment to write down. So you can pause the video and write them out, or you can just follow along. So here we want to determine if the variable is discrete or continuous. So part A says the number of siblings. So will this be a discrete or a continuous random variable? Well, this will actually be discrete. And the reason why it's discrete is because the number of siblings is basically going to be no decimals. They're just whole numbers or integers. Okay. Part B, the number of people in a car. So we're talking about people. People cannot be broken down into decimals or halves or fractions. So this is also going to be a discrete random variable. Okay, the weight of a submarine. Well, the weight of a submarine can also be expressed as a decimal. So it can be expressed as maybe 2,000.3 pounds. So you can actually express the weight of someone as a decimal. So this was going to be continuous. The amount of time spent waiting for the bus. So time can also be expressed as a decimal. So this is also going to be continuous. Okay, so not too terrible to be able to describe them. So now that we know what actually random variables are and how they actually work, let's go ahead and define the probability distribution function. Okay, so probability distribution function. And the way that we're going to call this, instead of writing everything out, we're going to call this PDF. Okay, so this is what a PDF is. So it's just a function that provides the probability of different possible outcomes in an experiment. Okay, and the way that we can kind of express this is either with a table, with a graph, or with a function. Okay, so that's basically what a PDF is. It's just a function that provides the probability of different possible outcomes in an experiment. So you can actually put it as a table, as a graph, or as a function. And one of the things to kind of know about probability distribution functions is that all probabilities must add up to 1. Okay, so the probabilities of all of the distribution functions can add up to 1. So one example, let me give you an example of a table. So an example of a distribution function that has a table can look something like this. So x here is what we're going to be the random variable, and then here is going to be the probability of x. So I mean, let's say x can only take on 0 and 1, and then probability of x is going to be 0.3 and 0.7. So notice here that this table actually adds up to 1, because if you see all the probabilities here, they're going to 0.3 plus 0.7 is going to give me 1. So this is a probability distribution function. So here's an example of that. The next thing, a graph. So when we talk about graph, here maybe is this a particular example for a graph. When we talk about probability in terms of a graph, we basically are talking about the area. So you might look at something that kind of looks like this. Okay, so something that looks like that. So if you look at this graph, all of the area that's under this particular curve is going to be equal to 1. Okay, so the way that you kind of find the area, well, if you look at this, this is a triangle, and if you remember, the area of a triangle from geometry is 1/2 base times height. Okay, so I'm gonna take 1/2. The base is gonna be this lower part. Notice that this lower part is only 2 units away, so the base is going to be 2. And the height is going to be the height of this triangle. Notice how high it is. Well, it's going to be on the y-axis. It is 1 unit. So if I put this on my calculator, 1/2 times 2 times 1, that just gives me 1. So you see that that also is a probability distribution function because everything adds up to 1. The last part, which is, we're not really going to be working a lot with these, but they exist. So these are just functions. So basically, if you had something that looks like probability of x is equal to 2 times x, here x can take only on the values of 0 and 1/2. Then basically, here is a function that you would probably see in algebra. The way that you want to be able to make sure that they add up to 1 is that you got to plug in the 0 and the 1/2 and add them. So you got to plug in probability of x equals 0 plus the probability of x equaling 1/2. Okay, so when I plug in 0, you're going to get 2 times 0. And then when I plug in 1/2, you're going to get 2 times 1/2. Okay, this is going to go away. Half of 2 is going to give me 1. So then you see that this is also a probability distribution function. Okay, so don't worry so much about the functions. We're not really going to be dealing a lot with them, if anything. So I do want to be able to give you a probability density function, and you should be able to gather information from them. So let's just do one quick example. Okay, so given the following, okay, so let's say you have this, so a table. Okay, so you have 0, 1, 4, 5, and 6. Okay, and you have these following things. So you have 1 over 11, 3 out of 11, nothing there, 1 out of 11, and 2 out of 11. Okay, so here is what I want to be able to do. Find probability of x equal 4. Okay, find probability of x being less than 4, less than or equal to 4. Then find the probability that x is less than 4. Okay? Okay, so how do we do this particular problem? Well, part A, you have this probability distribution function is a table. Notice that this table is sideways, so you can either have it vertical or you can have it sideways. So x tells me that x can only be 0, 1, 4, 5, and 6. These are the only possibilities that you can have. And each of these possibilities occurs with this probability. So 0 occurs with a 1 out of 11 possibility. 1 occurs 3 out of 11. 5 occurs 1 out of 11, 6 occurs 2 out of 11. So what we want to figure out is what is the probability of x equaling 4? So what is this probability? Okay, so when 4 happens, what is going to be that chance? Well, what do we know about probability distribution functions? Well, we know that all of them have to add up to 1. So that means that 1 out of 11 plus 3 out of 11 plus, I don't know what that is, so I'm just going to write x, plus 1 out of 11 plus 2 out of 11, all of these have to equal 1. Okay, so what I'm going to do is I'm going to add all of these guys up. The 1 out of 11, 3 out of 11, 1 out of 11, and 2 out of 11. Okay, so you can put this in your calculator or you can just add it in your head. So 2, 3, 4, 5, 6, 7. So this is 7 out of 11. So I got 7 out of 11 plus x is equal to 1. Okay, now in order for me to solve for x, I'm going to minus 7 out of 11. Okay, so x is equal to, so what is going to be this probability of x equaling 4? So I'm going to do 1 minus 7 out of 11, and you're going to get 4 out of 11. Okay, so this guy is going to be 4 out of 11. Okay, now there's many different ways that you could have done this. You didn't need to set it up as an equation. You could have just added everything up, 1, 3, 1, and 2. That gives me 7. How many more numbers should I add up to get 11? 11 out of 11, so that would just be 4. So there's many different ways that you can do this problem. Okay, now here what we're looking at is find the probability that x is less than or equal to 4. Okay, now this means less than or equal to, okay? So whenever you see something that looks like that, this just means less than or equal to, okay? So that's what this means. If you have something that looks like this, that means greater than or equal to, okay? Same thing with this, just means less than, not equal to it, but less than. This means greater than, okay? Oops, not that, than, okay? So for this first problem, you want to find the probability that x is less than or equal to 4. Well, that means you have to be very careful because everything that's less than 4, well, it's going to be really easy because it's everything to the left of this. So this guy is less than 4, and this guy is also less than 4. And we're looking at the probability that it's less than 4. So the first one is going to be 1 out of 11 plus the next one, which is going to be 3 out of 11. Okay, now the question here is, am I including the 4 also? Well, yes, I am, because it's equal to. So I'm going to also include the 4 out of 11. So plus 4 out of 11. So the probability of x being less than or equal to 4 is going to be the sum of this, which is going to be 8 out of 11. Okay? And now the last one says, what is the probability that x is less than 4? So the probability that x is strictly less than 4, okay? So everything that's less than 4, let me choose a different color, okay? So let me choose purple, okay? So this guy is still less than 4, which is going to be 1 out of 11. This guy is still less than 4, which is going to be 3 out of 11. Now, am I going to include the 4? No, because if I'm looking at everything that's less than 4, it's everything less, strictly less, not including that 4. So I'm going to go ahead and just take the sum of this, and you're going to get 4 out of 11. Okay, so this problem, there's a lot to it, but a lot of it is not too difficult. Just be careful with your less than's and your greater than's.